Hello friends, welcome back to my YouTube channel Study of Science with Rahul Kesherwani. Today I will start the new topic, that is electrophoresis, which is the electrical properties of colloidal solution, right? In the previous video we discussed about the different properties of the colloidal solution, but now in this video I describe the electrophoresis, that is the electrical properties of the colloidal solution. So what is electrophoresis? Electro term is coming from the electric field. Phoresis means movement. So what is electrophoresis? This is this is colloidal solution. This is U tube, and in this colloidal solution are placed as you know, in the colloidal solution disperse phase as well as dispersion medium both are present, right? This is colloidal solution. We place in this colloidal solution a plate, right? Metallic plate. And attach with it with a source of voltage, that is potential, means battery. We attach this metallic plate with the battery, right? During this process, all the colloidal solid particles move to one electrode or both electrode. Means as you know, colloidal solid are negatively or positively charged, so they are moved to that electrode on which they get neutralized. If this colloidal solid have positive charge, then it moves towards the negative plate, and if this colloidal solid have negative charge, then it moves towards the positive metallic plate, right? So this movement of colloidal solid particles in the influence of electric field called as electrophoresis. So what is electrophoresis? It is the movement of colloidal particles towards electrode in the presence of electric field called as electrophoresis. Electrophoresis. So this is the concept of electrophoresis, right? Now the concept of coagulation or what is coagulation or flocculation? Coagulation is a process in which the colloidal particles are aggregate to each other to form large size particles. So what is coagulation? It is the process in which colloidal particles aggregate each other to form large sized particle which ultimately settle down and precipitate. Actually, the precipitation of colloidal particles is due to presence of electrolyte. Means when we add some electrolyte in the colloidal solution, then the colloidal salt particles get settled down. Actually, precipitation occur due to addition of electrolyte, right? When we add electrolyte in colloidal salt, then colloidal salt take up the opposite charged particles from electrolyte. Thus, neutralization occur. That's why precipitation occur. Right? So this is the concept of coagulation. क्या है coagulation? When we add some electrolyte, then the colloidal particles aggregate to each other to form large size particle and then get settled down. This is the concept of coagulation, right? Now what is the flocculation? So what is the flocculation? Actually, when we add the electrolyte, a small amount of electrolyte, then we shake that colloidal solution, then it get back into the original state. Right? Now the concept of flocculation. What is flocculation? When a small amount of electrolyte present in a colloidal solution, then this process is called flocculation. When a small amount of electrolyte is present in colloidal, then it is called flocculation, and it can be reversed by shaking. By shaking means अगर उस solution में small amount of electrolyte present और हमने उसे shake कर दिया, then it go back to the original state, then there is no coagulation takes place, right? When we add higher amount of electrolyte in the colloidal salt, then complete coagulation takes place, and this process is called coagulation, right? When we add higher amount of electrolyte, then complete coagulation takes place. Right? What is flocculation? What is coagulation? When a small amount of electrolyte is present, then it is called flocculation, and when higher amount is present, then it is called coagulation. Right? So now what is the flocculation value? Now what is flocculation value? Flocculation value oblique coagulation value are precipitation value. Right? It is the minimum amount of an electrolyte in millimoles must be added in 1 liter of colloidal solution to bring complete coagulation, called as flocculation value, coagulation value, oblique precipitation value. Right? Smaller the coagulation value of an electrolyte, greater is the coagulating power. Means smaller the coagulating value an electrolyte, greater is the coagulating power. Means ऐसे समझिए कि अगर हमारे पास दो बीकर हैं, इसमें भी कोलाइडल सॉल्यूशन, इसमें भी कोलाइडल सॉल्यूशन, एक इलेक्ट्रोलाइट 1 है, एक दूसरा इलेक्ट्रोलाइट 2 है. हमने इसमें सपोज दैट 2 मिलीमोल इंटर किया और ये भी 1 लीटर है, ये भी 1 लीटर है, और इसमें ऐड किया और दे रिक्वायर 5 millimole for coagulation. So which one have greater coagulating power? So this one have greater coagulating power because it requires, this colloidal solution requires a small amount of electrolyte. So ये इस electrolyte की amount कम लग रही है, smaller the coagulating value, means जो value है, smaller the coagulating value, then greater is the coagulating power. इसकी coagulating power ज़्यादा है, इस वजह से इसमें हमें 2 मिलीमोल्स भी ऐड करने पड़े, जबकि इसकी coagulating power कम है, इसी वजह से इसमें हमें 5 मिलीमोल ऐड करने पड़े. राइट? इसी के रिस्पेक्ट में एक साइंटिस्ट ने अपना एक लॉ दिया, एंड दैट नेम ऑफ द साइंटिस्ट इज हार्डी सुल्जे, एंड he was gave a rule that is called Hardy-Sulje rule. So what is the Hardy-Sulje rule? Now Hardy-Sulje law. So it states that number 1, the effective ions of the electrolyte in bringing about coagulation are those which carry charge opposite to that of the colloidal particles. Means जो इलेक्ट्रोलाइट हम ऐड कर रहे हैं कोलाइडल सॉल्यूशन में, अगर अपोजिटली चार्ज्ड है तो उनमें कोएगुलेशन की पावर कोएगुलेशन बहुत तेजी से होगा. फिर से देखा जाए, द इफेक्टिव आयंस ऑफ द इलेक्ट्रोलाइट इन ब्रिंगिंग अबाउट कोएगुलेशन are those which carry charge opposite to that of the colloidal particle. colloidal particle का जो चार्ज है उसके अपोजिट में जो भी इलेक्ट्रोलाइट ऐड करेंगे उससे बहुत जल्दी से कोएगुलेशन हो जाएगा. I take one example to explain this point. As an example, if we discuss arsenic sulfide As2S3, this is a negatively charged salt. Negatively charged salt. For coagulation of this salt, we add electrolyte having ion opposite. Electrolyte having ion. क्योंकि ये निगेटिवली चार्ज है, we add aluminium 3 plus or barium 2 plus or sodium because this carry negatively charged and we add the positively charged electrolyte, right? Means अगर अपोजिट चार्ज मिलेंगे तो इजीली से न्यूट्रलाइज हो जाएंगे और बहुत जल्दी से कोएगुलेशन हो जाएगा. सेकंड, greater is the value of the oppositely charged ion of the electrolyte being added, the faster is the coagulation. Greater is the value of the oppositely charged ion. Mean जितना ज़्यादा oppositely charged ion होगा उतना ही तेजी से coagulation हो पाएगा. Means if we add 3 molecules of aluminium ion in this charged salt, then more coagulation takes place as compared to the when we add 1 molecule of aluminium ion, right? Now the third point, the coagulation power of an electrolyte is directly proportional to the fourth power of the valency of the effective ions. Mean जो coagulation power होगा किसी भी electrolyte की उसकी वैलेंसी का फोर्थ पावर होगा. जैसे एल्युमिनियम की यहाँ पर वैलेंसी 3 है तो इसकी 3 का फोर्थ पावर मींस coagulation power of aluminium, that is 3 raised to the power 4 means 3 into 3 into 3 into 3. So this is the coagulation power of aluminium, right? Now one more thing is that basically one question arises according to Hardy-Schultzy law. जैसे कह देगा कि if we want to neutralize the arsenic sulfide, we add aluminium, barium and sodium. So which one have greater tendency to coagulate it? As you know, greater is the charge, greater is the valency, more coagulation power. So which one is more coagulation power for this negatively charged salt? So aluminium have more power, then barium and then sodium. If we take second example as ferric hydroxide, that is positively charged salt. If we add phosphate ion, sulfate ion and chloride ion, so which one have more coagulating power? Which one have more coagulating power? As you know, this phosphate ion have 3 charge, so they have more coagulating power. So this one have greater tendency as compared to sulfate ion and then the chloride ion, right? So this is about the Hardy-Schultzy law. Thank you very much for watching this video. Like this video, share this video and also subscribe this channel. Thank you.